board.
It's a weather
Wireless
station.
weather station. Okay.
Yeah,
I
I didn't really get to play with board, but this
Yeah.
I have wireless working. Although I'll have to reprogram it to talk to this Wi-Fi instead of my home Wi-Fi.
All right. We're running late.
Go ahead and start up here.
And I'm doing this to show that the only thing we have is the Ethernet connection. And I want one of you to go to 192.168.1.160. Or heck, both of you. You can fight. I don't care.
All right, I'm there.
You should have a web page up.
LED.
So it says it says LED and it has a checkbox.
I checked it.
And it tells you that there's 5 analog outputs underneath of it. Click the checkbox.
I clicked it. Nothing happened.
There, they just came on, and you guys are fighting. You're both clicking it, so.
Oh, that's why. Okay.
Yeah, so one of you click it. Choose.
I stopped.
Okay. Well,
And the light comes on. If you click it, and you click it again, and the light will go out. So. Okay. There's something going on the network here. But so this is the Arduino wireless shield. I'll push a different one on here that you can play with. But the other one is I created a telnet server for it. So,
The olden days.
well, no, it's interesting. The nice thing about a telnet server type application is it is a challenge response type of thing. And so, let's see, that's a 04. Let me push that out there. Oh. So we've got a lot to talk about tonight. I said, it should be fairly easy to do this thing, and I ran into a gob of snags that were not really related to this. So now if you have a terminal program, do you have a...
Oh yeah.
Set it up to not telnet. Do not use the telnet protocol. Use a blank protocol.
raw.
I mean, you can do it, but it sends a bunch of bytes down the pipe first. It's going to do weird stuff.
I have a raw.
Okay, you're on raw.
What? NC.
No, I didn't set a port.
192.168.
Yeah, you don't have to set it on port 23.
3?
Yeah, port 23.
Okay.
Now, the first time you hit enter, it'll do a connection. Now, if you hit R, S, capital S.
Enter.
Enter.
No, you don't need to hit enter. Are you both connected or just one of you?
I might be. I don't know. I just killed mine.
Okay, now I see a heartbeat on the Ethernet. All right, try hitting just the 1.
Number 1?
Number 1. Okay, you're not connected.
Okay.
All right, let me go back and I'll try. S. Oh shoot! I hit enter.
Don't hit enter.
I just typed in S, capital S.
Nothing?
Nothing.
All right, you guys are going to call me liars. Am I on port 23? Yeah, I'm on 23.
It looks like I'm connected.
All right, then you try hitting just a 1.
Okay, I did. Let me try starting over. Let me actually, hold on. Let's start by killing all connections, just in case you're stealing something from somewhere. Okay, your thing is set up. So 160, 23, raw, open, enter, S, capital S. Okay.
No? 1 or 2?
1,
Or 2.
2.
All right, so you're not working. It works for me.
I hit enter and it gave me some.
Oh, somebody just did something.
Well, I hit enter after those, and it gave me.
Ah, so yours is set up to not send a character until you hit enter.
Okay.
That's what's going on. So, okay, hit S and then enter.
Yes, enter.
And what did it tell you?
LED 1 on, LED 2 off, and then all the pins.
And then it gave you the 5. Now hit 1.
1, enter.
Now hit 2.
2, enter.
Now hit 1.
1, enter. Yep. So, it's,
And if you hit S, it gives you the status. So it'll tell you what they both are, and it'll give you the 5 analog reads back.
so, yeah, just
So basically what we saw on the webpage.
yeah, without a web
Terminal.
interface.
Yeah, can you see it over here? It's
I can see.
So you can immediately see that this is useful, right? Because you can write a piece of software now, and all you got to send is a character or two back and forth, and then control it. Now, you shouldn't do what I'm doing with these LEDs. I'm using 2 pins to control an LED. I'm turning on the grounds on one, and then using the other one as a hot. And these LEDs don't mind being used like that. But some of the LEDs that I have do mind, like these little bitty red ones that are on here. They'll burn up if you do that. So I know, I've tried it.
Yeah, so just a raw, simple, basic, no frills connection,
Yep.
sending raw commands, causing effect.
Okay, so the standard Arduino Ethernet Shield has, I don't know that we're going to get to what we were originally going to talk about this evening, it's LCDs, because there is just so much I learned on these that I didn't want to learn.
Yeah, a lot of projects you want connectivity, so.
So you've got an Ethernet port, and you've got an SD card, a micro SD, back here. So, number 1, micro SD is a FAT16, which means that it uses the old DOS 8.3. So,
8 before the period and 3 after.
6, 7 dot Y, Y, which means if you use that as a string, that's 8, 9, 10, 11, 12, 13 bytes. Up to 13 bytes. Because you have to null terminate if that's a string. Okay. Lesson number 1. The Arduino talks to this whole mess over SPI. So we got Mosey, Meso, and clock, and Ethernet. We have 2 chip selects. Pin 10 is your Ethernet chip select, so whenever you send stuff to the Ethernet card, it uses pin 10 to say, I'm talking to you, I'm not talking to you, I'm talking to you, I'm not talking to you. If you're talking to the SD card, it uses pin 4, I'm talking to you, I'm not talking to you. So, if you're using the SD card or the Ethernet, you've lost these 2 pins. So you're already at 5 of your 13-ish pins. Right? Lesson number 1. Lesson number 2. If you have a SD card inserted and you are not planning on using the SD, you need to go in and assert pin 4 high into the chip not selected. Because what will happen is the Ethernet library will come out here and try to talk, and there's no telling where this is if you haven't actually specifically set it to high, because it's going to be low normally, which means he's going to be chip selected, and you're going to be banging bits out to this and this at the same time, and they're going to corrupt each other's data flow, and you're not going to work. So
That could eat a lot of time out of your life.
10 hours or so.
no, that was nothing. I found that early on, and I'm like, oh, okay, I've got this commented in my code. Do this, and I played with it once and took it out. I was like, yep, that don't work, and put it right back. It's like, okay, validated. So that's I don't know, what was that? This is This is lesson 1. This is lesson 2.
Is that handled by the Arduino library for you? Or
Okay,
is,
so-
because I know you like
yeah.
to dive deep sometimes. And,
No, yeah. Well, we talked about SPI 2 weeks ago, right? And actually 5 weeks ago also.
Right.
So those are lead-ins to be able to do all these other fun things, right? So in the Arduino libraries, the standard libraries, there's Ethernet. There's an Ethernet library. If you add it on, it'll stick the Ethernet.h at the beginning. There's an SD.h and SPI.h, I think. So last time when we played around with the SPI, I used the built-in SPI libraries. We talked about how it worked and the weirdness that happens with it. So if you go in and you say, I want to use the Ethernet library, and you say choose it, it will automatically add the SPI.h and the Ethernet.h up at the top. Or if you want to use the SD library, it will also automatically add the SPI.h. Is that right?
You said the Ethernet uses the SPI to connect, so I guess
Right,
the,
yeah.
and the SD card does too.
But
We don't have to worry about manually dealing with these
Right.
conflicts.
So these two libraries make calls out of that library.
Right. Yeah.
So you have to include it so that these two can work.
Right.
But you do have to physically go in your code, in the setup, and set that line high.
Okay.
If you're not going to be using this guy. If you're not going to be using the SD card library. If you are going to be using the SD card library, not a problem, because it's going to make sure that he's high when he's not being used.
Okay.
And that will keep them from walking all over each
So
other.
would that be only if you included the SD library but didn't plan to use it?
It would be, no. It would be anytime.
Okay. So if you're using Ethernet,
Just to be safe, regardless,
Gotcha.
I initialize the Ethernet library first, and then the SD library. The first thing I do is I go in and set bit 4 high, and then I come in and initialize the Ethernet library, so it talks to that.
Okay.
And then I come over here and initialize the SD library, and it talks to that. And now everybody's happy, because if you start off without setting him high,
yeah.
bang, problems happen. All right. So I'll give you, let's see, what did I do? I went through and I was following a tutorial myself, because some of the stuff I've done is just the very most basic. So I found a tutorial. It's on, dang, I can't remember the website now. It's a very good Arduino Ethernet tutorial that takes you through 90% of the way, and you'll still find bugs. And so then you spend time. So I spent a lot of time working through and figuring that out. So the first thing is, in the Ethernet code, I'm going to have to look at mine so that I can keep up with it here. Not tell you horrible lies. One of the first things you want to do, depending on what you're doing, you have to set up the MAC address of this Ethernet card. Now, if you take your Ethernet cards, when you get them, we talked about MAC addresses being the actual physical. If you look right there on the bottom of the Ethernet card, that's the MAC address for that card. So in your code, you need to get one of the examples. It's a string. It's a byte. MAC equals, and then it's 1, 2, 3, 4, 5, 6 hex double digits. And now the software knows that this is the thing.
How to address it.
The interesting thing is, I can tell it any MAC and it seems to work.
Yeah, it's probably
It's
just so you don't give it any MAC.
Probably. That's what I'm guessing. I was playing around with it last night and doing some DHCP work. And so I had assigned it an address and connected it to my router, which normally does DHCP. And then I turned on DHCP, and my router's like, well, you already had this address at that MAC. it just kept giving me the same address over. So I'm like, well, I don't know if DHCP is working or not. So I went and changed the MAC address to something different, and it gave me a new IP address. And if I would switch it back to the other IP address, it would give me the 1. If I'd switch it to the...
Yeah.
If I'd use MAC address A, it would give me one IP address. If I'd use MAC address B, it would give me a different address.
Until that lease expires.
Until that lease expires. Right? So, some weirdness, things to know about. I don't know what use it might be to you. Your mileage may vary. So, among the other things, there's also a... there's 4 things you can set up. One is, one's MAC, one's gateway, one's netmask, and one's IP. And then, so we'll come back to this. I think I can erase all this stuff here real quick.
And maybe DNS afterwards.
No. Not, maybe. I'm not sure.
Yeah, it might be further down the line.
I haven't got to actually putting a DNS on this thing
Yeah.
yet.
You only need that if your software actually knows how to
Talk to a
ask,
DNS.
Ask DNS. Yeah.
Right. So, we had, let's see, lesson 1 was what? SD card equals 8.3. Number 2 was high pin 4, which is the SD card source select or chip select. That's with the genuine Arduino. Some of the other Ethernet cards that aren't genuine Arduinos use a different chip select for that. Lesson 3 is the MAC address. Might matter. All right, so then there's so you set up these, it's byte MAC equals hex number, hex number, hex number. So you're just initializing an array right there, basically, and saying these are the values that go into it all at the same time. Then you come down here, if you're doing an Ethernet server, which is all I've done, there's a command, it's called Ethernet server. And you put the port you want it to be on there. 80 is HTTP, which is all of your web browsers. 22 is SSH or Telnet?
SSH.
Yeah.
SSH. 23 Telnet. So those are 3 standard ports depending on what you're doing. If you're setting up a web server, you want that to be 80 because most time, I mean, your Firefox, Chrome, Internet Explorer, whatever, will default to go into 80. You can tell them to do other stuff, but that's where they'll go to if you don't. So, and then blah, 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 blah. And then you do Ethernet begin. I'm sorry, that's not right, is it? No, it is. Ethernet begin. Dot. Is that capital or lower? Lower. And now this controls a lot of stuff right here. So, lesson 4 server port. Now, if you say Ethernet begin, so these 4 things here go into there. So MAC, gateway, netmask, IP. So you say whatever it's named, MAC, gateway, netmask. If you start with those, and I don't know if they have to be in a specific order, because I don't have them on MAC, IP, gateway, subnet. MAC, IP, gateway, netmask. If you put all 4 of those and put it in there, it's a static IP, it comes up with those, and it comes up pretty quickly right away, and it does that. So if you know what your network topology looks like and you want to put this on a specific IP address somewhere, that's what you do. And then you come here and you say server begin. Dot begin. So what we've done here is we've said these are things that go up behind the scenes. You're saying this is my MAC, my gateway, my net mask, my IP. This is the port that I'm going to listen to. Begin. Now this initializes the Ethernet chips with all of this stuff. Well, all of this stuff. And then when you say server begin, it sets up a listener on that port. As far as I know, you can only have 1 server running at a time. I don't know. I haven't tried doing more than 1. Maybe you can, maybe you can't. I don't know. I don't know if you can have it. There's also a client side to this. I don't know if you can have a server and a client running at the same time. Don't know the answer to that. Now, so lesson 5, static IP. Lesson 6 is if you only do this, just a MAC, it'll do a DHCP.
Okay. Convenient.
That is only true after Ethernet library 1.0 and greater, I think, or 1. Like below 1.0, that's not true. I don't know how you did DHCP. You actually had to go in and write the protocol yourself. But with the newer versions,
Just didn't do DHCP.
If you download the newest library and
It's
use the
there.
newest library, it does it for you automatically and it becomes DHCP.
So if it's not working, check your library version.
Yes. And you guys are going to have to keep me honest on time because, like I said, I forgot my watch and I don't have any idea what time it is. Okay. Now, I am not going to go into a lot of specifics. Quit that. No, that's not what I wanted to do. Oh, come on. I think it's that one. But there are a couple of little things here I want you to be aware of. Okay. Now, let's assume that we're going to do the web server. That's probably the most likely thing you're going to do. You've got your little weather thing sitting outside. You'll do a quick connect to it, and it'll tell you the time, temperature, how many cats are screaming, if I remember last time's bad examples and whatever else. So, sorry, I have to keep looking at this. When you make an actual connection, and I'm not going to go into what all goes on behind the scenes to make a connection, I notice it works a little So when I did the little telnet server thing, it doesn't connect until you actually send something to it, and it's like, oh my god, I got a connection. I think that's what happens with the Ethernet, that as soon as it sees a byte come in, it's, hey, I've got a connection. So you have another class called Ethernet client. Sorry, I'm going back to all caps. Little ones are lowercase. Ethernet client. And client equals server dot available. So here, this is like at the top of your loop, right? And so you've done all your setup, and now you go into the loop part of this, the game loop that just goes over, repeats endlessly. And it says server available function asks the server, do I have a connection? Is there a client attachment? If there is, this quits being a null pointer and starts being a pointer to a client that has come in, which is like when you two were connecting at the same time and the lights were going bonzo because you were doing something and you were doing something and I don't know what to do. It's because I can only set up one client at a time, and now you guys are walking all over each other. What happens is when you do your request, the HTTP, the Hypertext Transfer Protocol, sends a bunch of data that's about your browser, the machine you're on, your IP address. It poops it in there, and that lands. And we can, I've echoed that to the screen, but what you're looking for is a carriage return line feed. So in C parlance, that's a back R, a back N. And I think the back N is the new line.
Yep.
And the back R is the line feed.
Yeah, carriage return.
Okay. The two together make a carriage return.
Yes, but I thought the
So
yeah.
it goes back to typewriters.
Yeah.
A carriage return,
Yeah.
it returned the carriage and it rotated it.
Yeah, you're right. One of them is go to the next line, one of them is go to the beginning of the line.
Right, and when you're playing with a telnet terminal, you'll notice in your settings to see how do you deal with a carriage return. Is it a carriage return plus a line feed? Is it just a line feed? Is it just a carriage return?
I think that the new line is just advanced down, and the carriage return
Is to go back.
Is to return. It's a carriage return line feed.
Yes.
Yeah.
So, actually, it doesn't matter the order you do it in.
I think they.
But
do
for
like them-
HTTP,
Yeah.
it does matter.
Yeah, some things are very specific about that order because I've switched it before and had things not work.
Right. Because for HTTP, what it does is it says, I got a bunch of stuff to tell you, and then I'm going to do a back R. And then it's, I got a bunch of stuff to tell you, and I'm going to do a back R. And now I got a bunch of stuff to tell you, and I'm done, so I'm going to give you a back R back in.
Mm-hmm.
And if you look at all of the tutorials, what you're looking for is it a new line? No. What? Is it a new line? Yes. Yes, it is. Is the next character this guy? No? Okay, well, you're throwing more data at me. I'll keep taking data. I keep taking data until I see, is it an R? Yes. Is it an N? Yes. He's done talking to me. He's told me all about him. For this particular instance, I don't care. So now I'm going to reply. Or if you do and you parse this and you pull pieces out of it, I can come back and tell you, you've just logged in from IP address this. Right? What you do when that happens for a HTTP connection, you want to send back something similar to the following text. And I'm HTTP /1.1
There's an OK in there, I think.
200 OK.
only okay if it's 200 or 200.
And then you want to tell it what your content is.
Content type.
Yeah, I'm trying to get the capitalization right.
Yeah, capital C, sometimes space, sometimes dash, capital T type.
Is it colon or is it just a space? Colon space. Space. Text slash HTML. Now you just told the thing at the other end that I'm sending you plain text and it's HTML formatted. And once you do the response, once you tell whatever you're going to send back there, once you send it back, then you close your connection. Oh, no, I'm sorry. I lied. Now you tell the other end what you want him to do when you get done sending stuff. So here's you say connection close
Versus keep alive.
versus keep alive. So it could be close, it could be keep alive. So there's a couple choices you can do. And if you're and now we start to look at what a regular web page looks like, right? And you can put a command, you can tell it right here, refresh. I think there's a colon. So this is the beginning, you tell this stuff, then you dump the web page, and if you've written web pages, you know it's got an HTML header. It starts with HTML, then title, then slash title, then
HTML head. Title.
Head, title, slash head, body, whatever, slash body, slash HTML. Refresh file. So once you send all that stuff back and it hits the slash HTML, this end, your PC, the client says, oh, you're done, I'm going to close the connection. But he's also been commanded here to refresh in 5 seconds. So in 5 seconds, he's going to come back and make a new connection. This is all going to happen again. If you don't do that, it's not going to come back and make a connection. It's just going to load it the one time and be done. And so then you just, after this point, you spew HTML. So you start at HTML and you end at slash HTML. And that's the key here to do whatever it said to do there. Okay? So, number 7, let's see, what was the seventh thing we learned here? Was opening a connection. Open a connection. What you're looking for. Number 8 was a little bit of HTML handshake. Number 9 is HTML response, HTML server response. Ask questions at any time. Right now I'm like Bogart in the whole class. You guys are allowed to ask questions anytime. All right, now.
I guess I was trying to look. I don't see anything. So, based on what you've described here, this thing is completely unable to like protect itself. Is there? I was looking for a way to like say only allow this IP so that we couldn't clobber it.
I don't know enough to know. Yeah, you'd likely just handle that in your code. You could have
we're going to get somewhere here real quick where I'm going to tell you that I think you probably can do that, but you better be really damn clever about how you do it. So when you look at all of these tutorials up to this point, they have hard-coded into the code. When you want to write back, it's so you did the Ethernet client. It's client. And it looks a lot like the serial functions. There's client dot print there's print line, there's read, there's write, and a few others. So it is a serial connection going over the SPI to the Ethernet. So when you send stuff out, you treat it that way. And what you'll see is in all of the tutorials, which is what I just said, so I'm sorry I'm repeating, they're using the print line over and over, which means they're sending a \n, which is all, I guess. And they are hard coding in HTTP space, what was it, 1.1 space whatever, okay. So when you look at those tutorials, whatever the HTML is for the page, they're just puking it out as a print. Lesson number 10. Arduino memory has only got 2K of RAM. And as a sub-rule to that, there's only 32K of flash. I've handwritten web pages that are 25K. You know, I don't use fancy editors. I go in and my web pages are really stupid simple, and they can still be big, especially if there's a lot of text, which in mine there are a lot of text and links and whatever else. So, lesson number 11. Memory map. This is the Arduino memory map. This is the Atmel AVR ATmega memory map. When you write your code in the IDE, static data is instantiated. So anywhere where you hard code a 5, he's sitting down in here somewhere. Anywhere where you hard code a print line, blah, 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 down here somewhere is going to be blah, blah, blah. So, that whole web page is filling this up. Now, when you call a function, do you remember us talking about popping and pushing way back at the beginning? If I call a function, especially if it's an interrupt, I take my current registers, some of them, that are doing things, and I say, oh, wait a minute, I've got to hand some stuff off over to this other process now. I'm going to take this current data, and I'm going to put it up here in a stack, and it starts at 2K, and it starts growing down. So if I do a recursive function, which is, if you know what a recursive function is one that calls itself. One of the most famous one of those is doing the Fibonacci sequence. You tell it, do 10 things, and it goes, and then when it gets to the 10th one, then it rolls itself, it return, and comes back up. Well, if I do that 10 times, I've done this 10 times, and this thing grows. And then as I come back, it shrinks back up. And it grows, and it shrinks back up. And if I build a whole bunch of shit filled up here, and my stack comes down and hits, I've just had a memory collision, and now I've overwritten things with other things, and all those things were important. And now weird shit happens. And that is one of the hardest things to troubleshoot in the whole freaking world, because you got no clue what's going on, because you got no way to inspect the memory in real time to see what's going on.
And it doesn't protect itself.
And the more print statements you put in there, the more
To
this
try to
happens.
debug it.
To try to
The
debug.
quicker it happens.
Yes. So, lesson 12.
Don't do that.
Memory collisions suck.
Yes, in this
Memory
stage,
collision.
I would not have thought about that.
I know.
Because it's just unlimited.
Are easy
Everything has so
and
much.
they suck. All right. Now, if you're a C coder like I am, and you say, oh, I'm going to be clever, and I'm not, okay, I'll have some hardwired, but I'm going to use malloc and I'm going to use free. Malloc is to come in here and allocate a piece of memory and use it, and then when I'm done with it, I free it up, and that comes off the heap. So whatever your static data is, and whatever your stack is, that's how much heap you have. And so you start right at the top of your static data, and you say, you know what, I need 256 bytes for a string. And it's going to go, and it's going to do 256 bytes. And then when you say free that pointer, it's going to move the pointer back down here, and it's going to say, great, we're good. What happens if I say, oh, I need, let's see, these are bytes. So what happens if I need to do an 8.3? What did I say? That's 13 bytes. So there's 13 bytes for file name. And oh, I need another file name because I'm going to be talking to the SD card. So this is file name 2. And then file name 3. But you know what? I'm done with file name 1. So I'll free that memory. So this is free. But my heap pointer is still here. And so the next time that I want to do an allocation of memory, it's going to start here, and it's not going to know nothing about this. This is called fragmenting your memory, just like an old fragmented hard disk, right? So now I do another one here, and I've got file name 4 to go do something with, and I want to free up file name 3. Well, I've got a blank spot, but I've got used memory and a blank spot and a used memory. And as far as my simple compiler and everything knows, I'm just filling up my memory. I am just filling up my memory. Especially if you're doing this dynamically, this chip doesn't know. It's not a smart chip. It just says, oh, okay, this is where my heap pointer is. I start there and give you some more. Unless I go back and free all of this, I'm going to keep using memory. This is not exactly a memory leak, but it looks like a memory leak. A memory leak is when you don't free memory after you're done using it. And so now you're slowly leaking memory.
You freed it but can't use it.
Right. Here we freed it, but I can't use it. And if you get onto a modern PC, there's things that run in the background that say, oh, you know what? This is, the operating system starts handing things around and says, oh, no, this is here now. And so we can keep our memory from getting too badly fragmented. That and the fact that, like, if you're on my machine, you got 24 gigabytes of memory.
You don't even have to do that often.
Yeah, big deal. So this grows and grows and grows and grows. Now this was a complete surprise to me. Because I'm looking at this and I'm saying, you got all this flash RAM, you know this is a static variable that never changes, why in the hell are you putting it here? That's dumb. And it is dumb. But the thing is, it doesn't know that, right? I mean,
It's too dumb to know it.
well, I think there's flags. It turns out there's a flag. So lesson 13 is, lesson 13 is fragmented memory. So, lesson 14, clever use of constants. And pointers. if, for instance, I'm putting troubleshooting stuff in and I want to say, error, this failed, success, this passed, just so I can set my way through the code. If I say success, success, success 10 different times, well, then I've done however many bytes success is times 10 bytes down here in my static data. What I can do is I can come up to the very top with a constant car pointer, right? A little string that says success, and now I use it exactly one time. It's right here, and throughout my code I say, oh, hand me that string over here and I'll print it out now. So now I pass a variable, and that variable is actually a pointer to a car structure, a string, for all intents and purposes. And so now if I've got 500 little success statements in there, now I'm only going to use one success here instead of using up all of this. Clever programming trick number one. The next is you could play games with pointers. And you can do pointer math. So if I want to do the whole alphabet, and I don't care if it's all uppercase, it's only 26 letters. So if I can know how to move through there, right? Pointer math says maybe 0 through 9, A, B, and so on, is address. Think of it as just one piece of memory, and the address is 0, the address is 1, 2, 3, 9, 10, 23. I can spell out a word, a sentence, whatever, by coming back here and saying, print this one, print that one, print this one, print that one, that one, this one, that one. You can save a lot of memory doing that, but you can use up a lot of your brain cells trying to figure out how to write that dang sentence, right? That is a way of doing this. Lesson 15. Write to Flash. Lesson 15. Your program space is out here in Flash. Zero to about a half a K is the bootloader for the Arduino. And then when you write a piece of code, it puts it all right here. And then as the instructions are executed, they make these different things in memory happen. And so the instructions are here, the data is here. That's Harvard architecture, right? So what you can do, there's two ways of doing this, and I've only used one because I haven't quite figured out how to do the other yet. So here where I say print something, you can say F. That F, whatever the something is in between the parentheses, that is a flag to the compiler to put those here and not put them there. So for certain things, you can get away with this, and that says, oh, this thing is in Flash, I should read that out of Flash, and the compiler says I should never write that into memory, I'm just going to keep it in the Flash. Make sense? Very useful when you're hungry, when you're starved for memory. Because when you're writing all these web pages, you're starved for memory. Now, there's another way to do this that I have not explored yet. So we talked about F just now. There's also called progmem. which is also a flag to the compiler. So if I come up here and I say, if I want to get clever and I want to say, oh, well, I'll use a constant, right? And then I can use that in multiple places. So if I say constant car name equals something, the way I would tell the compiler to write that something over to here is to use this progmem. I think it can go here or it can go here, if I remember right. But if you use the progmem, reading it back out of memory is non-trivial. There's a couple of special internal flags that you have to use, and you have to come in and you have to read it 1 byte at a time, which means you have to know how long it is a priori and some other things. At least the only examples of this that I've seen are that way. I don't know of any other way to say, hey, I want to use this thing 37 times. You'll have to write a special function to go read it. And that's not so hard, I mean, if you know that it's this much. But you got to be careful because, again, you can run off the end, you know, off by 1 and get some goofiness happen.
So is there any way to tell that you've exceeded your memory other than it breaks?
What got me running down this track was because I figured, I think I got a memory problem here. And I started looking for, there are some people who've written some very simple functions that will basically count from here, from the heap pointer up to the stack
wherever
pointer,
the bottom of the stack is,
and come back and tell you this is how much memory you got. And they will understate the memory a little bit because they have to use their own variables to be able to figure out where the stack and where the pointer are and some other things. But then they have to print you results, which uses a little bit of memory, and just that in and of itself can cause your program to crash, right? Because if you're running really close here,
yeah, it doesn't take much.
Schrodinger's
what I
memory.
did, yeah, Schrodinger's memory. What I did notice is that if you have less than 500 bytes of RAM free, the Arduino IDE warns you. It says you ain't got much memory left. This could cause problems.
Okay.
And it'll have the, you know, it will still compile. It will stuff it out here, but
If
have a
you
nice.
actually look, it will.
You'll have a nice orange warning down the bottom at the end of the
Okay.
compilation.
And that's just for the program you're pushing. That's not, hey, I just write in a meg worth of HTML data, because it can't know that until it executes.
Well, if you did all of the HTML data in hardline print
Yeah, but
mode.
I'm saying if you write it from a remote server or something, yeah, I can't know that.
Yeah, and so that was one of my first run-ins with this memory problem was, you know, I'm going through and I'm reading this stuff and it says, okay, now do this. And I was running ahead of them a little bit and trying to get clever in some of the stuff, and then it suddenly wasn't working, and then it was a question is, well, am I too clever for my own good? Is there something going on here? And what I was finding is they're using the string function. They are using the string class in their examples. They're using the string class to build the HTTP request string. So that whole thing, when you commit, so that there's a form on there that gives you the checkbox, and when you click that button, it resubmits, and in the header it says, I'm sending you this form has changed this thing. And they're basically looking in that whole big chunk of memory that came down, that data that came down, for is that in there? And if it is, then we'll just flip it. So they get a little bit further on, and they actually check to make sure that it was the right one and whatever else so that it stays synchronized. But I got to good enough and quit because I'd been 3 or 4 days of typing on this. I'm not kidding, 10, 15 hours of learning some of these lessons, relearning other ones, and finding all these pitfalls as I'm going through. Because like you said,
You don't. We're not trained to think that way
We don't
anymore.
think down that low that often anymore. And most of the stuff I've done, when I've done this, I've been very careful about my memory because I knew I didn't have much, and this was my first real dive into this. So what would happen in my particular case, these two things would collide, and when it was trying to do that string find, it would always tell me it wasn't there. When I was printing it out right there in front of my face, and I could see it, and I knew it was there, and it kept repeatedly telling me, no, that's not in there. I'll try a different string. No, that's not in there. So I actually went down the rabbit hole of what are the functions of string and what kind of things can it do, and they're not well documented either, it turns out. And in fact, the way that they're using them in the Ethernet tutorial is not documented in the string library. So once I figured out the memory problem was the problem, all of a sudden this non-documented way of doing things started working. And that was one of the things I was wondering, it's like, well, is this wrong and it's not been updated or what? So, now, you can do this, getting clever or writing it to Flash. But again, if you've got any kind of a web page, any kind of a serious amount of data, eventually you're going to run out of this too, because it's only 32K. But aha!
That's why they put that flash thing on that.
That's why we got a frickin' SD card on here. That SD card, this SD card is 32 gigabytes. I got 32 gigabytes of memory on that thing. I'll never, I'll be like Bill Gates. I'll never use that.
Yeah, 640K.
Nobody will ever use more than a meg. Oh, also, memory collisions make the SD library not work. Also. Which was one of the other problems, because I'm hitting all these things at the same time. I'm like, what the hell's going on here?
Yeah. Which am I troubleshooting?
Yeah, what am I troubleshooting? It just quits working, and I don't know what I'm troubleshooting.
Cascading.
So 16 is, lesson 16 is SD handling. It's very easy. At the very beginning, you want to, you have the, it's exactly like the serial library. Serial.begin, baud rate, whatever else. Here it's SD.begin, and it's your SD chip select pin, which is pin 4 on that thing. And once you do that, I don't have it on this one, I have to close that one up. Serial begin, pin mode, serial, Ethernet. Where is it? I pulled all of my comments out of here. Oh, this is the wrong one. Let me open up the one I want to look at here. Make sure I'm not telling you lies. Yeah. And if this is successful, I think it's true, equals success, false, equals fail. Yeah, 0 and 1, I think. Looking at the code real quick, that's what it ought to be. And now you've just created a file system. SD card running around in the background is basically creating a way to do a file system. And similarly, it has an open, a close, a read, a write. Oh, at the end of Ethernet, whenever you get through your client connection, you need to do an Ethernet. You need to do a client.close, and that'll close that client and kill that connection so that somebody else can connect, or so you can start over. There are some nifty things. I actually wrote my own function to do reading from the SD card. If you look at the SD card tutorials, there's some very simple ones. What is it, SD open? So in C, this is a type, file type. It's a pointer to a file stream, and yeah. So if I say file pointer, that is a pointer, also known as a handle, depending on what language you're using. If I say FP pointer, or F pointer, I'm sorry, file pointer equals SD dot open, I'm sorry, do it right. File name. If that file exists on the SD card, it will return a pointer to that. If it does not, that will be a null pointer, which means it points to nothing. But usually a 0 or a -1. Usually -1. Actually, it can be negative anything, but it can be a lot of things. But anyway. Well, if I'm doing this, I can rapidly eat up a lot of memory. So in mine, up at the very top, I defined the constant care thing, and I just called the names one after another. But once it's open, if you do an open with just the file name, it opens it as read-only. You have actually this. You have file name, two different flags, read only, or is it write or read write?
Right.
Oh, I'm sorry, it's file read.
File read.
File read or file write. There's SD open, there's SD delete. So you can open a file. If a file does not exist, it creates it. If a file exists and you call a file delete, it deletes it. If you have a file open, always close it. I believe that the older SD libraries, okay, I know for a fact that the older SD libraries could only have one file open at a time. I'm not positive, I haven't tried it, but from what I've read, the newer versions of the library can have multiple files open at a time. Clearly not more than 1024 because you don't have that much memory. And it's FAT16, so you can probably only have 256 at the most, or 128.
Yeah, I forget what the number is, but yeah, it's low.
It's small. So what I did on mine was, I took all my HTML. When you saw those web pages pop up, that HTML is sitting on that SD card. And I have, remember we had the HTML response. That is its own little file. Then we have the HTML header. That is its own little thing. And then the first part of the HTML body, the last part of the HTML body, and the form changes, right? Because you saw a different form. That was the only thing I was doing in code, was changing the form. So I'd get my HTTP response, I'd say, or my HTTP connection, I'd say, here's the response, here's the header, here's the first part. I'm going to go over here and do this and poop that to you. Now I'm going to come over here and throw you the last part of the web page, and then I'm going to close the connection. And so by doing that, I was able to knock my memory down a little bitty. So SD handling, what else do I think? I got to put my code up online so you guys can get to it. One of the things that I'm doing, this is one of these things. Remember I told you before, if you ever see that if you're writing code and you see that you do something twice, make a function, because you're probably going to do it more than twice. And even if you do it twice, then you're only writing it once. Well, remember what we talked about with the stack coming down. This is something that bites your butt when you're low on memory, because now every one of those is a function call, and every one of those is putting something on the stack. Every time you go out to run a function, you're throwing something on the stack. And so it's okay if you go out here and you run it and you come back out of it, not a problem. But if you've got a function and now it calls a sub-function and now it calls maybe some other function, and we don't know how much of this is going on between Ethernet and SD and the SPI library. Oh, I've got a function here, well that goes on the stack. Well, I've got to do this other thing here, so now that goes on the stack. And oh, in the middle of all this, I'm telling you what I'm actually doing is printing something there, so that's taking a piece of memory, and that's a function that goes onto the stack. And so your stack's rapidly coming down and eating up what little memory you have left.
And on the topic of conserving memory, I think a few weeks back, or a few sessions back, we figured out the difference between a constant and a define. Where a constant
defines are kind of deprecated and
yeah, but just for clarity, because you still see defines used in some examples or some people's code, but a constant stores it once and then everything is a pointer back to that. Where a define, the compiler will take the definition and copy it to every place that exists, which takes up more memory. Of course.
Yeah.
It doesn't necessarily. It depends on the compiler.
Yeah.
Because that's at the compile time, right?
Right.
So it all depends on.
But if you want to try to do it right and conserve memory and not rely on the compiler to do the smart thing.
Yeah. and the thing is, the compiler this is using the GCC compiler, which is a really smart compiler. It's also a cross compiler. It can do all sorts of things, but they've hidden all that from you. And I don't know how to go in and change those options to make it. I mean, it's
a way to see the options.
There's like a config file somewhere that you can do that, and I don't know.
So back to the real quick, the define versus constant. I think that there were examples where you wanted to use define because some things could possibly change at some point. So they might be dependent on something else. So it wouldn't necessarily be the same as a constant. I don't remember the examples, but it was.
When you're doing your header files, you use defines there, because when you go through, let's say, I've got the SD library, right? So the Ethernet uses the SD library, and the Ethernet uses the SPI library, and the SD uses the SPI library. So we called out the headers. And what those headers do is they're pieces of code that get stuck right at the very beginning of all your other stuff, so that when it goes through and does all these references, they're already there, right? I know what those references are. So if I define a bunch of variables in SPI, and then SD comes along and says, oh, I need those variables from SPI header. Oh, well, we've already defined it. Well, shit. So now you need an if-def. If it's already defined, don't use it. And so what you use is you use a define in there to say, hey, I've already defined this, and this is
Right.
And what'll happen if you don't do that, and if it didn't catch those things, you would instantiate the SPI library, then the SD library would come over here and make a new instance of it, and then the Ethernet would make a new instance of it, and they would be trying to talk to the same thing at the same time
Right.
through two different hooks, and then you'd have collisions.
Right. In PHP, they have a include once and a require once, so you don't include or require the same file more than one time. Yeah, same sort of collision issue.
What else horrible lessons did I learn the last couple days? For me to go through through the first 5 Ethernet tutorials was quick. It was at like the third or fourth one where I started being clever, and it was the first one they said, this is how you do it, and then this is the second one you do this, and then the third one, hey, this is how you use the SD card. And now they went back to going back and doing the other stuff. I'm like, well, screw that, I'm going to keep using the SD card. So I wrote functions to make things easier, and then my stuff quit working, and I spent all these days working out this memory problem that gives us all these other little things about memory collisions, memory maps, and everything else in the middle of it. And then when I got that done last night, to write that little telnet server thingy, that took me less than half an hour. Because it's dumb and it doesn't use any memory at all. And I was just like, I just want to see if I can do this. If I tell this to listen on port 23 and I sit here and open up my terminal, what happens? And I'm sitting here, everything that goes in is puking out on my console. I'm kicking it out on serial the whole time as I'm watching it. And, okay, I see what's going on. And yippee-yi-yi-ki-yo, that worked. I'm sorry, yippee-yi-yo-ki-yay. Nah, that's actually a song. I know, because I had to get up on stage when I was like 6 and sing it.
Poor you.
Written by Sammy Davis Jr.
Oh, wow.
It's a tongue-in-cheek, like a Cadillac cowboy. I'm an old cowhand from the Rio Grande. You can look that up and find the words. It's from there, probably. What time is it?
8:39.
So I spent an hour regaling you with 16 lessons learned here.
Do not follow in my footsteps, for I know not where I go.
Yeah,
Got anything?
Having fun?
Nothing.
Have I been speaking in tongues?
yeah.
Okay.
I mean, I'm trying to follow along the best I can.
It's so
some of it's
simple.
making sense, but some of it's kind of like
Well, let's figure out how to get back down under your head. That doesn't sound right. Not over your head. Let's get you down to your eyebrows, something like that. Let's.
Yeah.
Let's have it come back and smack you.
That's what I say. Ask questions. This class is for you guys. It's not for me. Don't be intimidated by these yahoos who know everything.
Just years of
doing that.
staring at this and going, what? So yeah, we've all been there. None of us are born knowing this stuff. So sometimes it just takes a little while to soak in, but yeah, if you have questions.
I need to sit down because my back's been killing me all week. What's?
I guess I'm just letting it soak in.
Well, do you want to go back in time? Do you want to? I mean, I'll turn this off so I don't have to. So somebody doesn't have to watch me repeat things that I did 6 classes ago. But I mean, do you want me to go through some of the basic electronic stuff? Do you want me to go through?
Yeah.
All right.
I used to live electronic. That's what
All right. So again, I don't know if I explained this last couple times you were here. I started off with the basic electronics. I'm looking at this from the point of view of the average maker, right? You don't need to know all the. I'm going to lie to you by speaking half-truths. I'm not going to inundate you with equations, because there can be a lot of them. But if you're wanting to go tinker around with something like the Arduino and make your own little projects that do neat things, I want to get you to the point where you can go do that, get you over that hump, and then you can start learning on your own, right? And then I'm here as a resource if you have questions. Then we can get into it. So I'll kill this, and we'll start talking about some stuff. Goodbye, everybody. Bye, Dr. Nick.